Welcome back. We are working on number 8 and writing a question that will model the data that's in this table, where we have an x value on the top row here, or x values, and we have y values on the bottom row. Now, before I started this video, I put into my plot, or into my stat plot here, I put the x values in L1 and the y values in L2. So the way you do that, you hit stat, and then you hit enter, and then you can move the little arrow keys to move these around, and you just type in the numbers. Okay? Then you go to y equals, hit the up arrow until it's on plot 1 and hit enter, and if you move off of there it should kind of be blacked out, and you may have to change your window. So look at the x values here. X values are really small. Y values go all the way up to 69, all the way down to negative 36. So if you look at my window, I made sure that I matched that on the y values. My y value, I made it lower than negative 36. My y max, I made bigger than 69. And when you hit graph, look, we see these points. Okay. So thinking back to what we did on the last assignment, where we looked at functions and their shapes, and we try to determine things about it. What could we determine about this function? If it comes from up here and makes its way down, then I know some things about it. I know that it's an odd degreed function because it starts up here and ends down here. Okay? If it's even, like x squared, it'll start and end, either both up or maybe both down, but never opposite. This is odd. Okay? Then it looks like it goes down and then maybe back up and then back down again. So I'm even going to say that more specifically it's up, down, 1, 2, 3. I bet it is cubic. And because it ends down, I know the equation is going to start with a negative number. So I'm going to write all those things down. That A is negative, and I bet it is cubic. And I also know the y-intercept is 3, so the constant term will be 3. And get that from right here. So let's see what happens when we do our successive differences here. Finding the difference between y values. Okay, negative 37, negative 5, 3, negative 13, negative 40. Whoa. What in the world? Sorry, I was looking somewhere else. Negative 53. Yeah, that's right. Okay, not the same. So it is not linear. We'll try the next one. Find the difference between these. And we get negative 32, negative 8, 16, and 40. Also not the same. So it isn't quadratic. We'll try these. This would be negative 24, negative 24, negative 24. So these they have in common. That means it is, in fact, cubic, because the third difference is what they had in common. This is a function then that can be written in this form: ax cubed plus bx squared plus cx plus d, where a, b, c, and d are just the coefficients on those different terms. From this table, I know that d is equal to 3. Put that over here, d equals 3. And from this information, looking at the common difference, you can find out what a is. So negative 24, whee, there's my pad acting out. So the third difference, if the third difference is the same, then negative 24 is equal to 6a. We talked about this in the very first video, so go back and watch that if you haven't. But cubics, this common difference will be equal to 6 times the leading coefficient. Okay? Always 6 times the leading coefficient. So that means the leading coefficient here, a, is negative 4. How do we find B and C? Well, remember, we always get the end ones, but we don't get the middle ones unless we use some points from the table. If I want to find two more unknowns, I need 2 points. For example, 1, 6. That is an x and y pair that this equation right here is supposed to satisfy. If I put in an x of 1 and a y of 6, the equal sign here should hold up. So 6 should be equal to a, which is -4, times x cubed, which is 1 cubed, plus b, which I don't know yet, times 1 squared, plus c, also don't know, times 1, plus d, which is 3. We got to do some simplifying. The beauty of using the point where x equals 1 is that that just simplifies to this equation without the x's in it. -1, that's -4, plus 3 is -1, equals 6. So 7 is equal to b plus c. Now, I'm going to use a different point. What a purple. That sounds fun. I'm going to use the point 2, 1. So again, this is my x value, this is the y value. My equation should work for this. When y is 1 and x is 2, there should be a value of b and a value of c that makes that true. 2 cubed plus b times 2 squared plus c times 2 plus 3. So we got to do some simplifying here. 2 to the third power is 8. 8 times -4 is -32. 2 squared is 4. That makes 4b. 2c plus 3. This is -29 plus 4b plus 2c is equal to 1. Add 29 to both sides. 1 plus 29 is 30. It's equal to 4b plus 2c. So I have two equations here that have the same two unknowns. That is known as a system. And it's one that I can solve with elimination, with substitution, by graphing, by using matrices. There are so many ways to solve this. And I'm going to show you elimination here, and then on the next video we'll do number 9, and we'll use a matrix for that one. Okay, but you can use a matrix for this one too. All right, if I want to solve this by elimination, then the coefficients in front of either b or c needs to be the same in both of these. Okay, the easy way that I see making that happen would either be to divide this one by 2 or to multiply the red equation by 2. And that's what I'm going to choose to do for this example, times 2. So what happens when I multiply that by 2? I get 14 equals 2b plus 2c. And now I'm going to bring that purple equation over half. 30 equals 4b plus 2c. Wow. All right, now I got to do some, if I want to get rid of c's, 2c minus 2c minus all of this is how I'll get rid of c's. 14 minus 30 is -16. 2b minus 4b is -2b. Divide by -2 on both sides, and you get that b is equal to 8. And once I know that b is 8, I can go back to this equation. 7 equals 8 plus c. So c equals -1. All right, so now it's time for the payoff. We can write the whole equation. I'll choose, let's do this sweet orange color. Nah, that color. I like that. Y equals -4x cubed plus b is 8, 8x squared. C is -1, so minus x. D is 3 plus 3. I believe that's the equation, but we can check it. Okay, so I've got these graphed. I get y I'm going to type in this equation. Let's see. Need a little more space. Negative 4x squared, no, cubed, plus 8x squared minus x plus 3. That's so satisfying, isn't it? And if you hadn't graphed those dots already and you weren't sure those points, and you weren't sure, you hit second and graph once you type your equation in, and look, the XY table matches this perfectly. So we've done it. That's number 8. Equations in the purple box. Well done.